We've found dozens of rocky habitable zone planets and 0 confirmed atmospheres. A spectrograph just caught LHS 1140b leaking helium, and you can't leak an atmosphere you don't have. So what exactly is LHS 1140b? Strip away the headlines and it's a rocky world sitting inside its star's habitable zone, the not too hot, not too cold band where temperatures could let liquid water pool on a surface. Astronomers have found rocky worlds there before, but pinning down whether any of them actually holds an atmosphere has been one of the field's biggest challenges. And calling this one a second Earth badly undersells how alien it is. It carries about 5.6 times the mass of our own planet. It doesn't even orbit a sun-like star. It circles a red dwarf, a class of stars far smaller and cooler than ours. And that cool little star is exactly where the trouble starts. Here's the problem with red dwarfs. They may be dim, but they're violent, regularly spewing deadly ultraviolet radiation. That's the bottleneck the whole search for life keeps slamming into. The galaxy's most common stars might simply be atmosphere killers. So the question was never just whether a world sat in the habitable zone, it was whether it could hold on to an atmosphere at all. Pointing the wine-red spectrograph at the Magellan Observatory in Chile, researchers watched helium escaping from LHS 1140b. That escaping gas is the fingerprint of an atmosphere that has likely survived for more than 3 billion years. And the way they caught it might be the cleverest part of all. This detection didn't start at a telescope. It started as a prediction. A theoretical model argued that LHS 1140b should have an upper atmosphere rich in helium, slowly bleeding away into space. To test it, researchers waited for a rare alignment, a night when 2 of the star's planets crossed its face at the same time. The other planet came up empty, showing no sign of an atmosphere. But LHS 1140b lit up with exactly the escaping helium signature the model had called. The field went from wondering whether rocky planets even existed to finding them common, to hunting for the first one proven to hold an atmosphere. And that clean win hands astronomers something bigger than one planet. Now the reality check, because the hype runs ahead of the science here. Helium by itself cannot sustain life. It's chemically inert, useless to biology. What makes it thrilling is what it implies. The study suggests more life-sustaining gases could be layered beneath that escaping helium. Still, this is no cozy twin of Earth. Its radius runs about 70% larger than our planet's, and it's tidally locked, one hemisphere trapped in permanent daylight while the other never sees its star. Whether that locked rotation and the red dwarf's radiation quietly wreck any shot at habitability, astronomers honestly don't know yet. And that open question is exactly what makes the verdict so interesting. So let's answer it head on. Did we just find the first habitable planet with an atmosphere? Not quite, and the wording matters. What was actually confirmed is the first atmosphere ever detected on a rocky planet inside another star's habitable zone. Consider the odds. Of all the exoplanets found so far, only a few dozen are rocky and Earth-like. And before this, there were 0 confirmed atmospheres on rocky, Earth-like planets in a habitable zone. That's why a single detection reshuffles the whole target list, and researchers now call it the strongest evidence yet that such worlds can keep an atmosphere. Lead author Colin Cherubim calls it a model validation and hopes it's just the first of many more observations to come. But proving a planet can breathe is only the opening chapter. The next step is figuring out what that atmosphere is actually made of, and whether oceans hide beneath it. For now, one distant rocky world has proven it can hold its breath. Here's my read. I'd bet we are going to spend the next decade celebrating dead, helium-bleeding rocks, because the dream of finding a cozy Earth twin is quietly hitting a wall of violent red dwarfs. The real future of astronomy isn't finding a second home, it's learning to love these alien, tidally locked survivors. Stay patched.